to be here for this talk about shortening URLs, which basically is just a simple use case to tell you about how you can migrate your application to the cloud. And for that, I will be using Quarkus. You might have heard of it, Kotlin, Hazelcast, and also GraalVM, just to have a mix. Can you introduce me? I'm an old guy. I've been doing technical work for a long time. And now I'm mostly doing talks and blog posts and talking. And I still do a bit of development on the side, but yeah, I shouldn't tell it too much to my boss. I've started my career 20 years ago in Java. And recently, which means like 5 years ago, 6 years ago, I fell in love with Kotlin. The story is that I wanted at that time to teach myself Android. And then I started doing Android and I found that the API was really, really bad. And I found myself like wanting to have something that could be a bit better. And then I found Kotlin. I stopped doing Android and now I'm using Kotlin on the back end whenever I can. I work for a company called Hazelcast. You might have heard about Hazelcast. Hazelcast has 2 products. The first one is an in-memory data grid, and you can think about an in-memory data grid as distributed data structures. So you have multiple nodes, and you can either shard or replicate your data over several nodes. The other is called Jet, and it's a stream processing engine that does the work in memory. I won't talk about it today. Today I want to tell you about what I call the cloud gold rush. Like everybody wants to go to the cloud. If you don't go to the cloud, you are an old geezer. And well, like the cool kids, they go to the cloud. So why do the cool kids go to the cloud? There are several good reasons, and there are less good reasons. The not so good reason, like everybody is doing it, so we should do it. One good reason of migrating to the cloud is it brings you visibility. Like 20 years ago, people were talking about total cost of ownership. So when you bought hardware, you had to account for its price, but also for its energy consumption, also for the support that you got. You had to pay like support contracts. And well, you had to add also the people sometimes that were maintaining it if you were employing them. And so you had you had to add everything. And it was quite hard to compute because, yeah, like, you know how much you paid for the hardware, you know how much you pay for the maintenance contract, but how can you know like how long your people work on that exactly? And that's quite hard. So if you migrate to the cloud, you know exactly what your cost is. It might be higher than before, it might be lower. A lot of people think that it's lower. It's not always the case, but at least you know about it, and then you can manage it, because what is visible you can manage, what is not visible, well, you cannot do anything. The second reason is if you acquire your hardware, you have to account for the highest amount of compute and memory and whatever that you will ever use. I always use the example of an e-commerce shop with the Black Friday and the Cyber Monday, and there will be a peak of usage, and you need to buy your hardware according to this peak usage. And the rest of the time, your hardware is just there, you paid for it, it doesn't give you any benefits. So you have this flexibility, you pay like all the year, like flat rates, and then when you need, you pay more and you get more, and then back to normal. And something that I didn't realize until recently is if you are alone, if you want to start your business, this kind of stuff, I mean, if you have to acquire your hardware, you have a limit, you have a hard limit. You might be thousands of dollars, might be like $10,000 of dollars, but there is this step that you need to go. And if you are using the cloud, you don't have this step. You can be like gradual and start from zero until like something. And that is, if you are independent or a small team, can be pretty worthwhile. So now that we know why we want to go to the clouds, I imagine that everybody already has some software, and we want to have software running in the cloud. So there are three main ways. Well, not main, there are three ways. Either lift and shift, so you consider your software, you just like put it in the cloud, or you rewrite everything. And I hope that in this presentation, I will be able to convince you that there is a middle path, because, well, we will see the two first options, they are not really great. So lift and shift is very easy, that you say, okay, now I add my hardware, the cloud is just another computer, I just use my software as it is, I will deploy it on the cloud, and it's done. In general, it's quite easy. You just need like to containerize your application, because it's very hard to adapt to each cloud provider's infrastructure, but there is this abstraction that, well, you can run any container. So you containerize your app and it's done. Well, it might not be that easy as that. Worst case scenario, well, it doesn't work at all, because, well, it was not designed to be. But even if it works, you will probably pay a lot more than expected. The reason for that, for example, is that when you run on your infrastructure, you don't care about each CPU cycle. You can waste CPU cycle, you can waste memory, you can waste a lot of stuff. I mean, the hardware is there, whether you use it or not, it will be the same. On the cloud, since you pay for everything, you need to try to optimize as much as possible. And, well, if you like use a legacy application that was not designed for that, you might have like not so great surprise at the end of the month when you receive your monthly bill. There is this, like, I wouldn't say well-known, but quite widespread two-factor apps that cloud-native application must follow. So there are 12 factors, and we can, I won't like go through all of them, but you can find them pretty easily on the web. And a cloud-native app must follow those 12 factors to be considered cloud-native and to really use the cloud. And let's take a standard Java application, a Java web application, because, well, when you look at it, it's not great. So there is this second factor that says that a JVM application must declare all its dependencies. So imagine you are an old guy like me, and you have been using application servers such as Tomcat or Jetty, and so you deploy wars. And when you deploy a war, you deploy a war into a server. And so the server, the application server, or the servlet container, if it's Tomcat, is a dependency that you expect, but it's not a dependency that you declare. Okay. You are using Spring Boot, you are one of the cool kids, you deploy only self-executable jars, and so you embed Tomcat inside your application, because nowadays it doesn't make sense to have an application server that runs multiple wars. You just like embed your servlet container, everything is fine. Okay, but then the JVM is a dependency. And when you deploy it, when you deploy your jar, you expect the JVM to run your stuff. That's an issue. And that's an issue we have been like facing for years, is that the JVM version that you developed with must match the deployed JVM version, at least. So if you developed a JVM application with Java 11, well, the runtime must at least be Java 11, or it won't work. And that's not what you want. And that's another dependency that for us, at least for me, is like expected, but it's not declared. And so it defeats the second factor. Configuration. We have been taught, all people, we have been taught that, hey, we have an abstraction layer. So when you create an application, you don't pass directly the URL of the application, the username, and the password. You use a data source. And in each different environment, in development, in staging, in production, there is somebody who makes sure that the data source is configured to use the correct database. And so the fact that the application is independent is not correct anymore. You must configure every environment differently through the application server. If you are using containers, and like even more so if you are using Kubernetes, for example, you probably will be like starting pods and killing them very fast. And the idea behind the JVM is you start the JVM once and it runs for a long time. And for that reason, the JVM will take a long time to start up. Might be like 5 seconds, 10 seconds, you don't care. If you run for days, you don't care about those 10 seconds. If you run for 1 minute, it's not that great. Logs. Well, your application logs, your GSP servlet container logs, and they all logs in different files. So every application, you must configure the stream of the files to have one consolidated place to manage the logs. For example, you have Elasticsearch and you have I don't remember those beats, and you say, hey, there is one beat to read this file and this file and this file and send it to Elasticsearch. But in the cloud, well, your application expects to have the log in the std out, and then it's up to the infrastructure to put it somewhere. So at least those 4 factors, they are not really, they are pretty limiting regarding a traditional JVM web application. If at any point you've got questions, I will be happy to answer them because right now I'm talking to my screen basically. So if I can have more interaction, don't be shy and just write in the chat. I will do my best to answer them. So I was talking about the startup time of a JVM, but it's only the basic JVM. And we are using a framework. And yes, Spring or even Java EE, they are using reflection and class path scanning. And again, you've got an additional performance hit at the beginning when you start your JVM because of those 2 options. Doesn't look super great. So because of that, you might say, okay, I will rewrite the application from scratch. I mean, if you are a developer, probably that's the path you want to choose because, hey, it's not fun to maintain a legacy application, but everybody wants to start from scratch to have a greenfield application. It looks super great on your resume. But if you're a manager, you probably have a different idea. The first, obviously, is the cost. I mean, imagine you go to the business and you ask them for money. Okay, what do we get in return? Nothing, no business benefit. You will just spend money for nothing. It's very hard for a manager to ask for money without providing anything back. Hey, but it's to use the clouds, but the business doesn't care about the clouds. That's an IT concern. So imagine you are working in an organization that understands that it's better on the long term, and they give you the budgets. Now, as a manager, you have an issue. You have the problem of the delay, because when you start rewriting the legacy application, let's call it application B, application A doesn't stand still. The business still wants to do changes. And so imagine that it takes 6 months to write application B, Well, during those 6 months, application A will probably have updated. And so you are basically chasing a moving target. It's not great for the schedule. And yeah, if you have money, then you need to follow the schedule religiously. Of course, rewriting an application, it's always a risk. You will probably introduce bugs, whether you want it or not. You might have as many tests as you want. There will be bugs. And something about the organization is also interesting. Like, you run your team of X people. They maintain the application, the current application, the legacy application. So who will be writing the new application? Perhaps some of them, but perhaps you will need to increase your headcount for at least for a time. And so now you have employees, and perhaps you have an outsourced team. So who will be writing the new application? In general, the employees will be tasked to manage the new application. And the contractors, they will be tasked to maintain the old application. But they don't know the system, they don't know the old application, so they will be running all the time to the people who know about the application. It's going to be a mess. It's going to be a massive mess. So it's not unicorns and rainbows either. And I believe that there is a middle path. And the idea is to reuse the existing codes, but to leverage it in a completely different way. And when I say existing code, it's existing annotations, for example, like Spring and Java E. We probably are using annotations all over. But instead of running them through Spring or through Java E, we'll just have another engine that is smarter, or let's say is more cloud friendly. And second step, we will not run a JVM at all, probably not. We'll use native codes. And for that, there is a project by Oracle called GraalVM. You might have heard about it. The problem of GraalVM, it has many features, many different features, and there is this label, and it has different areas of effect. So the first, let's say, feature set of GraalVM, it's a JVM, a standard JVM by Oracle. So instead of using a G9 or whatever, you say, hey, I'm using GraalVM. Okay, fine. The second stuff is GraalVM is polyglot. One of the idea behind GraalVM is you have a rewrite of some languages that use a common framework. It uses truffle. And so the benefit is that you can run, I don't know, Ruby codes and Java code on the same platform, and they integrate with one another very well. So if you want to have an old legacy Ruby application and you want to integrate it, like to use a Strangler pattern, so you don't want to rewrite from scratch, you want to have a little bit of the new features written in Java, and then you move like slightly from Ruby to Java, you chop off bits by bits from Ruby to Java, then they can interrupt with each other in a nice way. And for that, GraalVM offers the Truffle framework. You might have heard about Truffle Ruby, which is a Ruby implementation using GraalVM. But in our contexts, the feature of GraalVM that is the most important and most interesting is called Substrate VM. And the idea behind Substrate VM is you have bytecodes, and ahead of time, you transform it into native codes. So the idea of the JVM is, the idea is you have this abstraction that like loads bytecodes, and it will over time compile it to native code according to a workload. That's the reason why the startup time is long. That's the reason why peak performance takes time, is because you need, and you might have heard about it, you need to warm up the JVM. And warming up means, hey, you need to execute the same workload over and over. And at some point, the JVM will say, oh, it always takes this path. This path, I don't need to interpret it anymore. I will just compile it natively, and then it will be very fast. That's the reason why the JVM not always, but at least in recent years, at least 5, 6, 8 years, has been performance of JVM has been on par with the performance of native executables because it learns from itself. And so instead of doing that, we remove the JVM completely, and this we do it statically ahead of time. And so we take the bytecode and we create a native executable. There are, I would say, some limitations. For example, reflection. The idea of ahead-of-time compilation is this ahead-of-time compiler will follow the execution path. So if the execution path is a simple execution of I call a method, it's easy. If it's like reflection, if it's class loading, if it's too smart, it won't be possible. So you can tell it, hey, you should follow this path also. But it requires, for a non-trivial application, it requires a lot of configuration. Another limitation is it's not cross-platform. So if you are building on a system, you will produce a native executable for this system. So if you want to build for multiple systems, you probably need to have different systems to work the same build on. Also, if you are using the security manager, which I believe nobody does, but if you do, then there is no security manager on this native bytecode, and so on and so forth. If you're interested, you can check. There is a limitations.md markdown, and it's quite extensive, let's say. So that gives us back to our initial problem. The JVM consumes a lot of memory. Native processes not that much. Startup time is long for the JVM. For native, it's much faster. The JVM, on the other hand, you write once, you can run on different systems as long as you have a GRE. When you are native, you are stuck to the platform you build it on. And the JVM can adapt to the workloads, native cannot. So there are pluses, minuses, but we can see that the benefits of the JVM in the clouds, they are not that interesting, but the benefits of native in the cloud, like less memory consumption and faster startup time, they are quite good. They are quite a good fit. So I believe that native is a good idea. So in general, what you will do is you will try to find libraries that are Graal native friendly. And there is a small agent that allows you to create like configuration files, for example, for reflection, as I mentioned. For non-trivial application, your configuration file will be quite long. You can create it automatically. So you will set an agent when you run the JVM, and then you will go everywhere in your application. Probably you have integration tests for that, or perhaps you have like manual testers. They will go everywhere. And so the JVM will execute all those passes, and the agent will record those passes and create those files for you. And there are already frameworks that are doing that. So you might have heard about Micronode, Quarkus, Elidon, and Spring Boot. Spring Boot also does it right now. And well, you just use them. You have your Java EE application or Spring application, and you use them, and you are able to create native executable. So I want to have a demo, otherwise I just like talked a lot, and that's not super interesting. And in that case, my demo is a URL shortener. But it's not a traditional approach. Traditional approach of a URL shortener is you create a bijection because between a big space of all possible URL and a short space, and you need to handle the collision somehow. What I'm doing is I will be generating random short links, and I will be storing the link between a long URL and its link, and also the reverse mapping. It's a trade-off, CPU time versus storage, but hey, I need a use case. So my stack will be a legacy Java EE application. I will be using Kotlin because I want to show you that Kotlin has nothing specific. The bytecode that the Kotlin compiler produces is perfectly compatible. Since I told you it's a legacy Java EE application, I will be using just JAX-RS, and I will be storing the data in Hazelcast and GraalVM. So that's my starting point. As you can see, I'm running on the JVM, and then I have a Tomcat. And so when my users makes an HTTP request, the Tomcat will handle the HTTP request through one of its own jar. It's probably Catalina.jar, and Catalina.jar probably relies on servlet.jar and JAX-RS.jar. And it will redirect this request, if it's valid, to my controller that runs in the war, that also relies at compile time on servlet.jar and JAX-RS.jar. And then the controller will make a call to Hazelcast MDG through one of the library that it has, which is the Hazelcast client.jar. And that's a perfectly traditional application. And I will rework it through Quarkus. And now I have this architecture. I don't have Tomcat anymore. I have like a JVM, and this is in development. I still keep my JVM in development. And now, instead of Catalina.jar, when I make a request, I have Quarkus that does its magic, that redirects it to my controller. And now inside, I have classes of like this former jar that will direct the request to Hazelcast MDG. And now with this, I can do some GraalVM magic and in production to have the same, but that run inside an executable. And I don't have the JVM anymore. I infer that is what happens, but I might be completely wrong. At least it will work the same way. So now I believe that I should show some code, otherwise you will be pretty bored to death. Again, if you have any questions, please feel free to ask them. So I have this application. This is my application. So I've been super lazy. I didn't start from a Java EE application. I used directly Quarkus with the command line, with the Maven to create Quarkus project, because it's slightly more involved to do that by hand, but you can do it any. And this is how it looks like. You've got a lot of configuration for versions. You don't use like, I don't know, is there anybody using Spring Boot? Are you mostly familiar with Spring Boot or with Java EE? Please just let me know. I will create a poll. Are you mostly more familiar with Spring? Spring, head option Java EE, head option none. Other. So please vote so I can understand what details I should like tell or not. Are you voting, or I don't know how to create that? Let's say I'm more familiar with Spring. I will vote on Spring. Yes, thanks. Okay, so I didn't know how to use that. So you are mostly familiar with Spring. That's good. That's also my case. So with Spring, and especially with Spring Boot, what you mostly do is you inherit from a parent POM, and then you've got all the nice stuff that comes with it. Of course, that means that if you have multiple modules, you cannot inherit from one of your own POM. Quarkus, though I think there is a parent POM, what they prefer is to have this like this dependency management POM import. So you don't have no parent, you can have your own parent. And what you do is you import from this POM to get the dependencies version. It doesn't work with the plugins, so you need to handle the plugin version by yourself. But otherwise, the results are pretty similar. Here I am using the latest version of Kotlin, and yeah, nothing mind-blowing. As I mentioned, I need to repeat the version here because I'm not inheriting from the version from my parents. And yeah, this is pretty normal in Kotlin. Nothing mind-blowing. Again, this is what the plugin does for me. I didn't write it by hand. I mean, it's a long stuff. And we can see here there is a profile named native. I will go back to it afterwards. The application itself, it's a JAX-RS, JAX-RS application. If you are familiar with Spring, well, you can think that this is a controller, and you can think that this is the post mapping. Here you need two different annotations, but otherwise it's the same. And you must tell it that what it returns can be plain, can be JSON, can be anything. So here I have like three different paths. The first one, I will create the shortener. So it takes a full value URL, and it will return a random string. I will append the prepend the prefix, sorry, and I will and I will put that in the shorten map. Then I have the get, that once it has been created, I get it, and then there is the delete. And I have actually two different maps. One is to store from the long URL to the short one. The other is to store from the short URL to the long one. And that is all I need. I have a random creator. This is pure Kotlin as well. And I have a little syntactic sugar. So what I want to do is every time I put something in one map, I should add the reverse, so the value key on the other map. And for that, I have something in Hazelcast called like add entry listener. And the issue with this is that the first value is actually could be a lambda, and the second is a Boolean. And it's not that great because in Kotlin, I want to have lambdas to be the last parameter, so I can use this short form and pass less than lambda outside of the parenthesis. So I've just added an extension function, and I love Kotlin for that. That allows me to reverse the parameter orders. That's evil, but it works super well. That's one of the reasons why I use Kotlin while doing Android, is because you can try to have a nicer API most of the time. At the time, it was not official. Kotlin was not official on Android. Okay, so let's try it. I will start Hazelcast. Start. So it starts like a node from behind, and I can run the application. And though I have compiled it just before, sometimes I don't understand why it takes so much time, but probably it will work at some point. It's a bit slow, I must admit, but it should work. Meanwhile, I will just like copy paste my posts because I'm super lazy. It's not normal. It takes too long. Something must be eating my resources. Now it has started. And now I can curl. So here I will create like one mapping, and then I will copy paste it here. Yeah, I'm super lazy because I need to do the like encoding, and I didn't want to do it. So here now, So I've stored everything. So everything is stored. I'm super happy. Great. And this is what I'm doing in development. No Tomcat, no nothing, just Quarkus, but I'm still using the GVM, which, again, not that great. So the idea is you can use debug mode, you can set breakpoint, you can do whatever you want in development, but in production you want to deploy on the cloud, you want to be cloud native. And so the idea is when you scaffold your projects, you will be creating those two Docker files. One that runs on the GVM and that we won't be using, and another one that you will be creating your image with. And honestly, I won't do it because it takes ages. But in the end, you can run the application like this. So I've created a Docker Compose file that will be running the application and also creating a Hazelcast image to just show you that it still works. So let's try it, Docker Compose. Now I'm using not Docker Compose, I'm using Docker subcommand Compose. I'm not using this. Now I'm using this experimental version that should work. And again, I'm getting here for. So it has started and everything works as expected. Now we'll be curling again. And of course, because it's random, I've got another one. And now I can just try to fetch it again. Yes, it still works. So I'm using the same codes, but the one was on the GVM, the other is native code. And of course, I expect to have the same results, which is pretty good. So that brings us to the end of this presentation. So my advice between, like just lift and shift and probably pay more and worst case, explode everything or rewrite the application is to walk the middle path when it's possible. If you have already a lot of software, so use it, you reuse the existing code as much as possible, but be smart with it. Use the frameworks that know how to leverage other framework codes. And Micro, Quarkus, whatever, they know how to use Java annotations. They even know how to use Spring Boot annotation. So just think about return over investment. It's really worthwhile. So thanks for your attention. You can read my blog. I publish a weekly blog post on Sundays. You can follow me on Twitter. You can find the original article. You can find the integration with Hazelcast. You can find the code repository that I just showed you. I just updated it today with the latest version. And if you are interested about Hazelcast and want to learn more, of course, please join our Slack. And now, if you have questions, I will be very happy to have them. Unless you are too shy, in that case, that's fine too. You can always ping me on Twitter or ping me on Slack.
So thank you very much.